So, Monday and Tuesday, we learned about translations, which were shifts in some direction, so taking either points or whole shapes and moving them based upon whatever translation, so up, down, left, right, etc. So, today we're going to move on to the next kind of transformation, and these are reflections. So, when you hear the word reflection, what do you think of first? For example, my brain thinks Mulan, but by extension, thinking about seeing someone's reflection, seeing your own reflection, usually you think about like a mirror, right? So reflections are just taking some image, some point, and reflecting it across something, okay? So let's just do a couple examples. This one is very, very visual. Translations was very much just like, okay, count, add this, subtract this. Reflections are much more visual, but we will have rules as well. Okay, so let's say I have a graph. Here's my x-axis, here's my y-axis. Okay, so maybe I have a point right here. And I want to reflect that point over the y-axis. Okay, the y-axis is this right here. You know that already. If we're going to reflect over the y-axis, that means this serves as our mirror. So whatever I see on this side of the mirror, I should see on the other side of the mirror. So I'm recreating this image by going across the other side. So notice that if this is my mirror, this y-axis, notice how I was 2 spots away on that side. So I'm 2 spots away on this side. Okay, it's a reflection. The reflection should be the same. Okay, let's do another one. So maybe this time I have a point. How about 3, 3? So I have this point, and this time I am going to reflect over the x-axis. So that means my mirror this time is my x-axis. Where's that at? Right here. So this line is my mirror, okay? So if I take this point here, I need to reflect it. So whatever reflection is up here needs to be the same down here. So for me, I like to kind of count it out. I'm like, okay, so this point is 3 spots up. So that means if I reflect it, it should be 3 spots down, okay? All I'm doing is I'm taking some image, I'm reflecting it over. Hopefully we're okay so far. We'll do a few more examples. So how about this time we have an actual shape? How does I'm trying to think. A rectangle sounds good. Might as well, right? Okay, so I've got my rectangle made of 4 points here. And I'm going to reflect it over. This time we'll reflect over a different line. I'm going to use this as my reflection line. And it doesn't matter that this isn't the x-axis or the y-axis. I'm still going to use it as my mirror, okay? So this pink line right here is what I'm using as my mirror. It's what I'm reflecting over. So I'm going to take my first point. I can start with any point here, but I'm going to start with this one just because it's pretty close to what I'm using as my mirror. Okay, I notice that it's 1 spot away. So that means when I reflect it, it should still be 1 spot away. Okay, I'm going to do this bottom point now. It's 1 spot away, so I'm going to keep it 1 spot away. Once you've plotted your reflection, it should literally look like you picked up what was on the other side and just flipped it over. Okay, so for this point here, I notice that it's 2 spots away. So I'm just recreating that same image. So again, it should look like I picked up this original shape and just reflected it over. A connection you can make here, think of this as being like a line of symmetry. Okay, if that helps you. Like I said, it's extremely visual, but at the end of the day, you can still just count it out. Okay? So those are our basics for reflections. Now I'm going to talk about some special cases here. So some special cases are if you're reflecting over something that's not just your usual, straight up and down vertical or horizontal line. So our special cases are reflecting over y equals x and y equals negative x. Y equals x and y equals negative x. Now these are 2 straight lines. If you remember when we graphed this first one, y equals x, it goes through the origin, it has a slope of 1, up 1 over 1. Y equals negative x, down 1 over 1. So you can kind of picture that these are 2 diagonal lines. So for example, here's my y equals x. So let's say I wanted to take the point this point right here. So let's say I want to take -2, 1. And I want to reflect it over y equals x. Well, in this case, you're going to have to use a little bit different rule. So when you reflect over y equals x, you need to take whatever ordered pair or ordered pairs that you have, and whatever your OG ordered pair was, for this rule, you're actually just going to switch their spots. Okay, so in this case, we started with -2, 1. That's the point that I was trying to reflect. So when I use this rule here, I'm just going to switch their spots. So my new point is 1, -2. Okay, so to show what that would look like here, 1, -2. And you can see that this sort of reflection is still happening. We just have to kind of go about it in a different way. Okay, now let's look at our other special case here. Y equals -x. So let me get a little graph going. So y equals -x, is a diagonal line through the origin. You should feel pretty comfortable recognizing that at this point. So let's say we have the point. You know what, this time let's use how about 3, 2? We're going to use the point 3, 2. And we're going to reflect it over y equals negative x. So we're reflecting over y equals negative x. So for this kind of special rule, whatever your ordered pair is, so I'm using xy to just stand for an ordered pair, you're going to switch their spots, but then you're also going to change the sign. Okay? You're switching their spot, but then you're also changing the sign. So in this case, 3, 2, switch their spots and change the sign. So we're going to go to -2, -3, which is right over here. And that is my endpoint. So to recap, most of these can be done visually. The ones that cannot be done visually are y equals x and y equals negative x, and then just use your ordered pairs and the rules, okay?